Okay, so we have a geometry problem here, that an enclosed rectangle problem. You see these again all the time in lots of different forms, but essentially this is what you do with them. So a veterinarian wishes to use 132 feet of fence to enclose a rectangular region and subdivide the region into two smaller rectangles as shown in the figure to the left. If the total enclosed area is 576 square feet, find the dimensions of the region. So I was nice to you, so you didn't have to read my writing. I typed it out. The stuff on the left, that picture on the left is pretty generic. I stole that off the internet when I typed in enclosed rectangular region problems. And so these occur quite often in tests and quizzes and algebra courses throughout the world. And so how I would set this up is very similar. We have a perimeter and an area. So if they give you a perimeter and an area, those are the two formulas I would use. So first off, I'm going to draw the picture so that it's a little simpler to look at. So we're looking straight down on the pins. And I'll stick with Y for the side lengths. And I'm just going to call this side, this whole length, X. Since the area of this rectangle, the entire rectangle, is just X times Y. And so this would also be X for the whole length. So our two equations. So first for perimeter. Perimeter in our case would be 2X plus 3Y. And so perimeter is probably a bad choice of words here. Our total fencing is what we're really looking for, but it's similar to perimeter. So I'll put total fence here in case some mathematician freaks out at my poor use of the word perimeter. Then area, the formula for area of any rectangle is X times Y, length times width. And so that's kind of all we need. Now, we know that our area from the problem is 576. So we know 576 is equal to XY. And we also know that 132 was our total fencing that we could use. So 132 equals 2X plus 3Y. And so in this case, let's go ahead and solve the perimeter formula for X. And actually you could really solve for any of them. If you want to challenge yourself, solve for the come up with a rational equation and solve for X or Y in that one. But we're going to stick to more simple things and just go ahead and solve this equation for X. So the first thing I would do is subtract 3Y from both sides. And so you'd have 132 minus 3Y equals 2X. Then divide by 2 all the way across. So I'll just divide this whole thing by 2. And I have a 3 written down there. Nice. So we know X is equal to 132 minus 3Y all divided by 2. And just like we've done in past problems, we're going to take this 132 minus 3Y divided by 2 and plug it for the X in the other equation. So now we'd have 576 equals 132 minus 3Y divided by 2 times Y. Okay, so now we're going to be distributing and solving for Y. We've got one variable. We're ready to roll. So we'll distribute the Y through. A common problem is people will sometimes distribute to the 2 as well, but really this is Y over 1, an improper fraction. So the Y only goes with the top, not with the bottom as well. That's a pretty common error when distributing these. So 576 equals 132Y minus 3Y squared. Then I want to get everything to the left, since this is a quadratic because of the y squared. And so we'd have 3y squared if you add 3y squared to both sides. Oh, whoops. I am forgetting something. I am forgetting something. Woo. Let's go back. I forgot all about the 2 on the bottom. And so it was y times 132 and y times 3y. And so we'd have 132y divided by 2 minus 3y squared divided by 2. The 2 would go with both things. Whew, that was a close one. We almost had a catastrophe. And so we need to eliminate this fraction first. So I'm going to multiply the entire equation by the common denominator of 2. And so you would have 1,152 equals, the 2's would cancel, so you'd have 132y minus 3y squared. Okay. Now I'm going to move everything to the left. So you would add 3y squared over and subtract 132y from both sides. So I'll just stick them over here so we balance out our equations. And so we'd have 3y squared minus 132y plus 152. And I put it in descending order so that I can factor it or use quadratic formula. To save time, I noticed 3, 132, and 1,152 are all divisible by 3. And you can do that just quickly by adding up the terms. Like 3 is divisible by 3, that's obvious. But 132, that's not obvious. But if you notice, 3 plus 2 plus 1, that's 6. And when you add them into the sum of the digits is divisible by 3, then it's also divisible by 3. And you can also do that with the 1, 1, 5, 2, which would be 5, 5, 6, 7, 8, 9. And so we know it's divisible by 3 all the way across. So I'm going to take out a 3, or simply just divide the entire equation by 3, including the 0. And what happens is you'd have y squared minus, let's see, 132 divided by 3 would be 44y plus 384. Now factoring n equals 0, because 0 divided by 3 is 0. So now factoring becomes a lot easier. It's going to be y and y minus and minus for minus plus. And now you just have to think about factors of 384. And 384, 4, and 96, and you could keep going, blah, 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 and keep breaking it down. And then you'd have to look for all the combinations. So you could use 4 and 96 here in the middle, here and here, but that doesn't give you 44. What does give you 44 is 12 and 32. And if you check that, it indeed does give you 44 if you FOIL it back through, distribute it back through. So now we can use the, I think it's called the zero product theorem, and we know that y minus 12, since the whole equation is equal to 0, we know y minus 12 could either be 0 or y minus 32 could be 0. And so y would equal 12 feet, or y could equal 32 feet. And so with that in mind, we go back to our original picture. And so if y is 32 feet, we'll start with 12. Let's say it's 12 feet here, 12 feet here, and 12 feet here. That means the width of our triangle is 132 minus 3 times 12 divided by 2. And so you can go ahead and figure out both of them. Then you also have to figure in the other answer, which the other answer is 32 feet. And so you plug that in as well. And so there's 3 y's. We know there's 132 feet of fencing. And so minus 12 3 times is 36. All right. Sorry if that jumped around on you. I just hit pause just for a second just to collect my thoughts. But 12, so since one is 12 feet, we can go ahead and take, we've got our original figure here like this, and each of these sides are 12. and we know we have 132 feet to work with. So 132 minus 36 is 96, I do believe. Divide that by 2, and you know each side has to be 48 feet long. So this is a 48 by 12. And also with the 32, you could do the same thing. So you got 32, 32, and 32. And so 32 times 3 is 96. So 132 minus 96, 12, 0. So actually 32 plus 4 probably be easier. So 36 feet, but again, you've got to divide that by 2 because there's two sides for here and here. And so we'd have 18 feet for both of those. So the dimensions of our pin could either be 32 feet by 18 feet or 12 feet by 48 feet. And so there you have it, and hope this helps, and I'll see you next time.